All right, this is a continuation of Chapter 4, Section 5, Integration by Substitution. So remember, we find a u substitution. I recommend the inside here, which is 3x minus 1. We calculate du. du is 3, dx in this case. Now we replace everything. So this becomes the antiderivative of u to the 4th power du. Find our antiderivative in terms of u, which is u to the 5th power over 5 plus c. And then we substitute back in our x's. So 3x minus 1 to the 5th power over 5 plus c. Next problem, we'll do the same thing. If you have two where they both look like they could be the inside piece, pick the one that's a little bit more complicated or bigger powers. So I would make u equal to x squared plus x. That way du is 2x plus 1, whole thing in parentheses, dx. And now I can substitute it, because we have the antiderivative of u du, which is u squared over 2 plus c. And substitute our x's back in. We have x squared plus x squared over 2 plus c. For letter C here, we choose our u substitution. U would be x cubed minus 2, that inside piece, which means du is 3x squared dx. Notice I can find both of those pieces, so we rewrite this as u to the 1/2 power du. Integrate now, we have u to the 3/2 power over 3/2 plus c, which is 2/3 times u, which is actually x cubed minus 2 to the 3/2 power plus c. And for letter D here, we choose our u substitution. I would choose this more complicated part, which is 1 minus 2x squared, which means du is negative 4x dx. And lucky for us, that is all right there. So we rewrite this in terms of u. We have 1 over u squared du, which is u to the negative 2nd power du. So we anti-differentiate. We have u to the negative 1st power divided by negative 1 plus c, which is negative 1 over u plus c. Plug our x's back in. We get negative 1 over 1 minus 2x squared plus c. And finally, the antiderivative of cosine squared of x sine of x dx. I would make our u substitution be cosine of x, because du then is negative sine of x dx. We just have to pull an extra negative out front. Antiderivative of u squared du. We get negative u cubed over 3 plus c, which is negative 1/3 cosine of x cubed plus c. In definite integrals, if we make a u substitution, we can substitute back over to the original variable and then plug in our values, or we can just adapt and change those values. So basically, if I use a u substitution, I plug both of my limits of integration into that u substitution function and just change the limits of integration. It can save me a bit of time. So for this one, we'll start by finding a u substitution that would be helpful. I would say, oh, x squared plus 1, which means du is 2x dx. I don't see the 2 anywhere though, so we're probably going to need to take a 1/2 out, x dx. So that means that just our definite integral part, we have a 1/2 out front, we have u cubed du. Now instead of bringing the 0 and the 1 with us, we are actually going to plug them in. So 0 would become 0 squared plus 1, which is 1. My lower limit of integration is 1. My 1 would become 1 squared plus 1, which is 2. My upper bound of integration is 2. Now we never have to go back to x's. We take the antiderivative of 1/2 u cubed du from 1 to 2. So that's 1/2 times u to the 4th power over 4 from 1 to 2. So that is u to the 8th power, u to the 4th power over 8 from 1 to 2. Plug in 2. 2 to the 4th power over 8 minus plug in 1 to the 4th power over 8. I get 16 over 8, which is 2, minus 1 over 8, which is 15/8. Now we could have gone back to 0 to 1 and substituted our x squared plus 1 back in here. But it saves a lot of time if we don't. So let's try another one. We start with our u substitution. In this case, I would say u should be 2x minus 1. Then du would be 2 dx. I don't see a 2 anywhere though, so I have a 1/2 du equals dx. I also noticed that I have this extra x hanging out, which means, like we did before, we're going to have to solve for x. I have u plus 1 equals 2x, which means u plus 1 divided by 2 is x. So our antiderivative, we got that 1/2 out front. We have u plus 1 over 2 divided by the square root of u du. All right, dividing by square root of u, that means we will actually multiply by u to the negative 1/2 power. That way I can distribute a little nicer. I'm going to pull this 2 out front also, making it a 1/4. So u times u to the negative 1/2 power is u to the positive 1/2 power, plus 1 times u to the negative 1/2 power is u to the negative 1/2 power du. Now we find our antiderivative. Oh, I lied. We didn't take our bounds yet. Sorry. Plug in 1 to u. 2 times 1 minus 1 is still 1. 5, though, becomes 9. So we're going 1 to 9 here. All right, 1/4 of u to the 3/2 power divided by 3/2 plus u to the positive 1/2 power divided by 1/2 from 1 to 9. I have 1/4 of 9 to the 3/2 power, which is 27 times 2/3, plus square root of 9 is 3 times 2 over 1, minus, we plug in 1. 1 to the 3/2 power is 1, which makes it a 2/3. Plus the square root of 1 is 1, which makes that 2. So I have 1/4 times 18 plus 6 minus 2/3 plus 2 is 8/3. So I have 24 minus 8/3. Which, I'm going to be honest, I'm just going to use my calculator for real quick. I have 1/4 times 64 over 3, which is 16 over 3 as my final answer. And now, integration of even and odd functions. If your function is integrable on the closed interval -a to a, if the function is even, then the interval -a to a of f of x dx is equal to 2 times 0 to a f of x dx. If it's an odd function, then an integral -a to a is always equal to 0. And so, sine cubed of x cosine of x plus sine of x cosine of x dx. If we think about this, is this even or odd? Well, sine Sine function is odd, cosine function is even, so what happens when I mix them all together? Well, let's plug in negative x. The sine of negative x is negative sine of x cubed. Cosine of negative x is just cosine of x. Sine of negative x is negative sine of x. Cosine of negative x is just cosine of x. We end up getting negative sine cubed of x, cosine of x, minus sine of x, cosine of x, which means this function is odd. And an odd function, the integral from negative pi over 2 to pi over 2 would give me 0. And there we go. So you have an assignment here.